It's a great honor to be invited to give a keynote at your conference. Unfortunately, Rawalpindi is a long way from Toowoomba, and I have 100 exam papers to mark, just about as many assignments, and I can't get away. So please excuse me for attending virtually by using Zoom to communicate with you electronically. Now, when I produced some notes, your local committee thought I ought to tell you a few things about myself first. My very first research job, well, vacation job over half a century ago, was in the aircraft industry. I suppose you can call that mechatronics. Long before the word was coined, I was testing operational amplifiers for a huge analog computer. And then I went on to design an autopilot, the SCP-6, and I found that that was flying till recently. And everything was fine, but I then went back after I got married to do research in Cambridge. Now, my daughter's godmother is Stephen Hawking's wife, but that's a totally different story. While I was there, I was researching into control theory, and then I stopped on to supervise research. And we had a great time. My team, for instance, we put single board computers, linked them together to make what must have been the world's first multi-computer system. And we applied things to typesetting, to acoustic source location, you name it. And one of the things there was that to get promotion, I had to go somewhere else. I went off to Portsmouth Polytechnic. As I say, my colleagues commiserated with me until I told them how much more money I'd be getting. Now, at Portsmouth Polytechnic, lots of interesting things happened. One of our main research projects, best funded, was called the Craftsman robot. Now, if I share my screen with you, share screen, I hope I can show you some video. We were using a robot to adjust things, energy regulators for part of a cooker. And lots of other projects span out of this, like the designing of the cooker clock, cooker timer, oh, you name it. But much more interesting than this was that one of the people in that company was mad keen on walking robots. He got himself a one-year Royal Society fellowship to join us and work on walking robots. And let's have a look at the next one. The very first one we made looked like a coffin on legs. It was interesting, but it didn't work very well. The inside was a whole mess of little BBC micro boards, and that was fine. But then we had the idea of wall climbing robots. So we went on to Robot 2, which is looking much more sophisticated, and that got the interest of local television, not local television, British television, and the press, and come on, go to the next. There we are. There is Robot 2 climbing up the outside of a building. And it also was on British television, climbing up this wonderful perspex sheet that somebody in the studio managed to scratch just before the transmission, but that's another story. It got the interest of the British nuclear industry, and they paid a nice lot of money to have Nero design, nuclear electric robot. And Nero, its job was to go inside the outer shell of a nuclear reactor, inside to the steel pressure vessel, and needed to attach sensors, do all sorts of interesting things. And so that was the start of yet another company. Now, then I suffered from arthritis every winter. English winters are pretty brutal. And my wife, she was brought up in Kenya. She didn't like British winters either. We decided to move to Australia. We came to Toowoomba, a sleepy little place about 100 miles to the west of Brisbane. And my first researcher on that, Sam Kubra there, he was working again on a wall climbing robot. He called that one the Stick. Now, a lot of these robots have ended up in the Powerhouse Museum down in Sydney. But that was fun. But there are more interesting things to do. There in Portsmouth, industry was bristling all around us. In Toowoomba, the big industry was agriculture. And so the sorts of things that we're looking at is using vision to guide a robot to follow rows of crops. And you've got to do that very accurately. You're chipping, cutting away to try and pull out the weeds, and you want to get as close to the crop as you possibly can. And any errors, again, mean you lose crop instead of the weeds. Well, we put together this funny tractor that had a camcorder on its roof. It had a 486 computer as the main thing to make it work. It was pretty primitive, but it did work. And there's video which the local people, I hope, have downloaded to be able to show you when I've stopped gas bagging. And they will show you this video where the tractor follows that row of crops very, very fast. Well, there's also a project on RoboCar, a funny little three-wheeled mobile that was for training cutting horses. Then we were interested in real cars, not just robocars. Out in the bush, you can see it's a dry place, and the cars do their own thing, and they get harvested. But we wanted ways of telling which animals were coming to a watering point. Were they cows, or were they kangaroos, or were they emus, or were they feral pigs? Because feral pigs do a lot of damage, and we harvest them too. There's a lot of money in feral pork. We were looking at machine vision for tracing the outline of the animal. As you see at the top, there's a picture of a cow. It's against a blue background, so you can't see as much contrast as a computer can, but automatically this function traces the outline of that cow. So from a megapixel, we're down to 256 bytes. If I show you over here, that is the profile. That's an S-psi curve, just 256 tangents. And there's little wiggles. If you're clever, you can relate those to the fun little features of the shape. But more to the point, you've got a really nice, easy template that you can compare against your nest of templates to work out what kind of animal it is. Well, let's just see if I've got one more picture. I think that was the last. Yes, it was. So I'll stop sharing, and you can have the joy of watching me again. So once more, I say, I do hope that you're going to have a wonderful conference. I hope that the presenters are going to get heaps of questions to their presentation, because it's those questions that make it all worthwhile, gives them the opportunity to rub shoulders, form new friends, form new colleagues, and I hope you're going to ask me a lot of questions too. So that's all for me, and I hope that you see some fun videos of the things we've been doing. Bye.